Hey guys, in this video series I'm going to show you how I made this all-in-one board game application. In this video specifically we're going to create the core classes, that is the base classes which all the games will extend from, and the classes which they'll all make use of. So let me give you my unofficial definition of a board game. So a board game is a sequence of game states created by the players making legal moves using coloured pieces on a board until a terminal state has been reached. Now with that definition we can pull out some of the nouns and make classes out of them. But before we begin, let me give you a quick overview of how it works. To keep things simple, I'm just going to show you the chess packages here. Otherwise it would look something like this. So the user interacts with the GUI, which creates a move object and passes it to game's makeMove method. This will then check if the move is legal by calling GameState's isMoveLegal method. This method does some basic move verification and then calls the pieces isMoveLegal method, which does further, more specific verification. Then if all of this is fine, isMoveLegal will return true. Then game will call GameState's makeMove method, which works similarly. It will do general move actions and then call the pieces makeMove method, which will do the pieces more specific actions. Now let's define these classes. We can start with colour because that's the easiest. We'll give it one method which returns whichever of the two it isn't. Now a move can be further broken down into a starting position and a destination position. So let's make a new position class. Positions have an X and Y. Because there are two ways to refer to a board's position, the human way as in A2, H5, and an internal programmer way, which would be of index 0, 1, 7, 4. I'm going to give it two constructors, one for each. We'll need to translate the human-friendly constructor though. Lastly, we'll add an equals method and getters and setters. Now we can add the start and destination positions to the move class, and I'm going to add some helpful methods to give us more information about the move. And we'll add the getters too. Now, piece is an abstract class. Each piece has a colour, a light symbol, a dark symbol, and a value. For example, in chess, the most valuable piece is a queen with a value of 9. The constructor will simply assign these values. We'll give this class two abstract methods, isMoveLegal and makeMove. Also a toString method which returns the appropriate symbol, and some getters. Now on to GameState. Remember in the definition I said a sequence of game states. It would be nice if we kept copies of each state. That way we can undo and redo moves. So I think we should make GameState into a doubly linked list. This way we can restore any board from throughout the game history. Now what should a game state have? What varies from state to state? Well, whose turn it is, the arrangement of the pieces. We should also store the last move made. In some games the actions available to a player varies depending on which move preceded it, en passant for example. We can make this class abstract. Now what operations will we need to perform on each game state? We'll need to check if a move is legal. Because this is the base class, it should only perform the most general legality checks, i.e. is the move within the limits of the board. Next we want to look at the piece that is being moved and check that it's the same colour as the player. Then we want to check that the piece can actually make that move. Next, we need a makeMove method. This simply calls the PC's makeMove method and stores the move. Now, just as we have a pre-move operation, i.e. is move legal, we also have a post-move operation. This will be an abstract method, but its implementations will use this method to notify the GUI of events such as game over or stalemate. Next, we need a copy method. By using the new instance method, it allows us to avoid using the new keyword, and so we can create an inheritable copy method. The only caveat is that in each subclass, we must include an empty constructor. Next is a method which returns a list of all positions where a player has an ally piece. And then a method which returns a list of all possible positions on a board. Next, we'll add an equals method. This will check that the arrangement of pieces and the player turn is the same. Next, we'll want a method to check if the board is terminal, aka game over. The general implementation will simply check if both players still have material on the board. Next, we'll want to give the board an evaluation function. This will be used by Minimax. An evaluation function is just a rough score indicating how favourable a board is to a certain player. For example, if the light player has all his pieces and the dark player has only one left, the evaluation function will return a very high score for the light player and a very low score for the dark player. The evaluation function I'm going to add here is just a material balance. That is the number of ally pieces minus the number of enemy pieces. Last method is getSuccessors. This returns all the possible game states which could possibly occur on the next move. This is needed for Minimax to determine which move is best. Now the user interface has only one method, and that is notifyGameOver. NotifyGameOver will be called in post-move notifications. Any UI wishing to interact with the board game model must implement this method. Now onto the game class. The GUI sends moves to the game, which makes sure the move is legal, creates a copy of the current board, makes the move on the copy, and then saves the board in the linked list. The reason why this is split over two methods will become clear when we do Minimax. In addition to makeMove, it also handles all the undo-redo operations. Last thing we need to do is go into the piece class and add the getSuccessors method. This is called from GameState's getSuccessors method. And that's it for now. Next we'll start working on one of the games.